Let's look at solving a radical equation that involves two radicals. So because we have two radicals, we're going to need to go through the process of squaring both sides of our equation 2 times. So let's begin by squaring both sides. This will eliminate the radical with the expression 2x plus 1, but we will need to FOIL on the other side. So we're going to square the left-hand side and square the right-hand side. So on this side, think of this as a binomial being squared. 3 plus the square root of 4 minus x times another 3 plus the square root of 4 minus x. So on the left-hand side, after squaring the square root that has been isolated, we have just 2x plus 1. On the right-hand side, we need to FOIL 3 times 3 gives us 9. 3 times the square root of 4 minus x, we'll just leave as that. Inside's another 3 times the square root of 4 minus x. And then the square root of 4 minus x times itself, or a square root squared, will give us just the expression inside the 4 minus x. So let's work on getting everything with a radical on one side, everything without a radical on the other side. So I'm going to subtract 9 from both sides, subtract 4 from both sides, and add x on both sides. So simplifying this gives us 3x, 1 minus 9 minus 4 gives us minus 12. And then we can also combine the like terms that we have here in the middle. So if we have 3 and then 3 more of them, we really have 6 of the square root of 4 minus x. We're now ready to square both sides again to get rid of the second radical. So I'm going to square the 3x minus 12 binomial, and then also square the right-hand side. We have to take care to FOIL here on the left-hand side. So 3x times 3x is 9x squared. 3x times a minus 12 is minus 36x. Insides give us another minus 36x. And negative times negative gives us a plus 144. On the right-hand side, when we square the square root, that will cancel out. Be sure to also square the 6. So 6 squared is 36. The square root squared is now just 4 minus x. Let's go ahead and distribute here on the right-hand side and combine like terms on the left. So we have 9x squared minus 72x plus 144. Distributing 36 times 4 is 144 minus 36x. Let's work on getting everything on one side of the equal sign. So I'm going to add 36x to both sides and also subtract 144 on both sides. So it actually cancels the constant term on both sides of the equal sign. We're left with 9x squared minus 36x equals 0. So this is a quadratic equation since it has an x squared. Our strategy for factoring here, for solving, is to factor since we have a GCF of 9 and x. So if I factor out a 9x, it leaves behind an x minus 4. Set each factor equal to 0. We're left with x equals 0 and x equals 4. Because we squared both sides of our equation in our strategy for solving, we now need to check each one of these solutions in the original equation to see if we have any extraneous solutions. So let's start with x equals 0. So plugging in, I'd have 2 times 0 plus 1 is equal to 3 plus the square root of 4 minus 0. So just simplify each side individually to see if they simplify to the same value. So we have the square root of 1 and 3 plus the square root of 4. So 1 is equal to 3 plus 2, or 1 equals 5. Since the two sides do not simplify to the same value, that tells us that x equals 0 is an extraneous solution, and we need to exclude that from our solution set. If we do the same thing now with our second potential solution, x equals 4, we have the square root of 2 times 4 plus 1, 3 plus the square root of 4 minus 4. Simplify each side individually. So the square root of 9 and 3 plus the square root of 0. So we get 3 equals 3. Since both sides simplify to the same value, that tells us that x equals 4 is a solution to this equation. So it turns out that we have just one solution. X equals 0 is an extraneous solution and must be excluded, and just x equals 4 is our solution.